In this example, we have ourselves a word problem and figure out what's going on. So it says a tank has 150 gallons of water at time equals 0. Water begins to be pumped into the tank at t equals 0. A different pipe is draining water from the tank at that same moment. So water is being removed from the tank at a rate, important piece of information. So it's being modeled by this. So this is our rate at which the water is being removed. Okay, so rate out is our v of t function at 3 times 1.08, so some sort of an exponential equation looking like that. So it's measured in gallons per minute. Water is being pumped into the tank at a rate of, so rate in is being pumped at this, so another exponential. So a negative, oops, let's do mt, negative 7 times 0.94 t plus 14. All right, so where m is measured in gallons per minute again. What is the total amount of water in the tank at time equals 23? Right, so at time equals 23, what we want to figure out is how much water has been pumped in, how much water has been pumped out, combine that, and then add it to the 150 or subtract it. Depends on what you got going on. Did more water come in or did more water go out? So our total amount in the tank is going to be, it's going to be water going in is us going to be the area under the curve from 0 to 23 of this equation of negative 7, 0.94 to the t plus 14, and then dt. Okay, and then we are going to be subtracting, so that's in, so that's a positive. We're going to be subtracting the area from 0 to 24, that we're going to, nope, 23. Okay, we're going to be subtracting this 1.08 to the t. That's the amount of water going out from that same time frame. And then we'll add the original 150 that was in the tank to begin with. So we're going to use calculator on these. So let's plug this stuff into our calculator. Let's figure out how much water came in. So we're going to go alpha F2 as a nice shortcut for us to do an integral. We're going to go from 0, 23. We're going to do probably a couple parentheses here. Negative 7 times, maybe I don't need that one, 0.94 raised to the t plus 14 dx. All right, so negative 7.94 raised to the x. All right, so negative 7.94 raised to the x plus 14. So this is going to represent the amount of water that came in. So we had about 236.13 in minus water going out. So same integral. 0 to 23, 3 times 1.08 raised to the t, dt. Okay, so that was 189.89 coming out. And then it will tack on the 150 that we started with. So more water came in that went out. So I can really just take this answer minus that answer plus 150 to be as accurate as possible. So we get a grand total of 196.24 gallons at T equals 23. Okay, so that was rates coming in, rates going out. Nothing crazy. We just got to realize that water coming in is going to be treated as a positive. Water going out is going to be treated as a negative. They're coming in and out at all these different rates, and they're not even being at constant rates, right? You have these exponentials that are messing with all of this stuff. So we use calculus to figure all that out, tack it on to what your original was, and that's how many gallons of water you would have at that moment.